On a quiet night, when you look up at the sky, you might see a few hundred stars. But each of those stars is a sun, many far bigger and older than our own. And here's what we know now. Nearly all of them have planets. That's not a theory anymore, it's a fact. In our galaxy alone, the Milky Way, there are over 100 billion planets. Now consider this. The observable universe contains at least 200 billion galaxies. Multiply that out, and we're talking about trillions upon trillions of planets. Statistically speaking, even if just a small fraction of those planets have the right conditions for life, a bit of water, a stable orbit, a protective atmosphere, then life shouldn't just be possible, it should be common. So if life is likely, and the universe is so incomprehensibly vast, where is everyone? In 1961, astronomer Frank Drake tried to tackle that question. He created what's now called the Drake equation, a formula meant to estimate how many intelligent civilizations might exist in our galaxy right now. The equation considers things like how often stars form, how many have planets, how many of those planets could support life, and how many of those actually develop life, intelligence and technology capable of communication. Depending on the numbers you plug in, you might get an answer anywhere from "we're totally alone" to "we're one of millions." Now let's turn the focus back on ourselves. Earth formed around 4.5 billion years ago. Life began pretty early, microscopic, simple stuff. But intelligent life? That took billions of years. And humans have only been sending signals into space for about 100 years. In the timeline of the cosmos, that's practically nothing, not even a blink. So what if alien civilizations exist, but their window of communication didn't line up with ours? What if they advanced a million years ago and burned out? Or haven't evolved yet? We could be like two people standing on opposite sides of a canyon shouting, but at different times. No one hears a thing. There's also the unsettling possibility that intelligence itself is rare. Life might emerge frequently, but intelligent, self-aware, tool-using life, maybe that's the real miracle. After all, life thrived on Earth for billions of years without evolving anything resembling human intelligence. Dinosaurs ruled the planet for over 150 million years. Not one of them built a telescope. So here we are, a young species in a big galaxy with brand new technology searching for others. The cosmic odds suggest we should have company. But the skies stay silent. No signals, no greetings, no evidence of distant civilizations calling out across the stars. That silence is more than eerie. It's confusing. And it leads to one of the most important and haunting questions ever asked about life beyond Earth. A question posed by physicist Enrico Fermi back in 1950. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Lab when he suddenly asked a question that would change how we think about alien life forever. Where is everybody? It was a simple question, but it cut through the assumptions we all carry. If intelligent alien civilizations exist, and the universe is old, vast, and full of stars and planets, then why don't we see any evidence of them? This contradiction between high probability and zero evidence is what we now call the Fermi paradox. Let's break it down. If even one advanced civilization had developed space travel a few million years before us, they could have explored, or even colonized, the entire galaxy by now. The Milky Way is big, yes, but not that big. Even moving at just 10% the speed of light, a civilization could travel across it in about 10 million years. That sounds like a long time, but the galaxy is over 13 billion years old. That's more than enough time for alien explorers, builders, or colonizers to have spread far and wide. And yet there's nothing. No ships, no probes, no alien ruins, no signals, just silence. This is the heart of the paradox. The math says they should be here. The reality, nothing. So what's going on? Some scientists suggest we're simply not looking hard enough. Our searches for alien life have been extremely limited. Programs like SETI, the search for extraterrestrial intelligence, have scanned only a tiny portion of the radio spectrum, and even that has only covered a small section of our sky. Imagine standing on a beach, scooping up a single cup of seawater and saying, "There's no life in the ocean." That's how little we've explored the universe. Others argue that aliens may be out there, but they're not using technologies we'd recognize. We rely on radio, but an advanced civilization might have moved on to something more efficient. Laser communication, neutrino beams, or quantum signals we can't detect yet. In other words, we might be listening on the wrong channel. But maybe the answer is darker. Some think that intelligent civilizations tend to self-destruct, that every species that invents advanced technology also invents the tools to destroy itself. Nuclear war, AI gone rogue, ecological collapse. These aren't science fiction. They're very real possibilities. And if that pattern holds across the universe, it could mean that life often emerges, but intelligence, or at least long-lasting intelligence, doesn't. Maybe the reason we don't see galactic empires is because they don't last long enough to leave a trace. This idea is sometimes referred to as the Great Filter, and we'll explore it deeper in a later chapter. There's also the possibility that aliens are out there, but they're deliberately staying quiet. It's known as the zoo hypothesis. Maybe Earth is like a cosmic wildlife preserve, and we're under observation. The universe might be full of intelligent life that has rules, like don't interfere with developing civilizations. They could be waiting for us to reach a certain level of maturity before making contact. Or maybe they've decided we're not worth the trouble. And finally, there's the scariest idea of all. We might be the first. Maybe the universe can support life, but it takes an incredibly rare combination of conditions to produce intelligent beings. Maybe we're the first ones to make it this far. And if that's true, then the responsibility is enormous, because it means we're not just searching for others. We're the ones who will define what life in the universe looks like. The Fermi paradox doesn't offer answers, just questions. Deep, unsettling, thrilling questions. And no matter which way you look at it, one thing is clear. The silence out there isn't easy to explain, but it gets weirder. Because if the aliens aren't here, and we haven't heard from them, then maybe we need to ask something else. So far, we've assumed a lot, that if aliens exist, they'd be sending signals or building massive structures, or flying through space in ways we could detect. But here's a sobering thought. What if we're looking in completely the wrong way? Or worse, what if we don't even know what we're supposed to be looking for? Think about it. Our entire search for extraterrestrial intelligence is based on us. Our biology, our tools, our methods of communication. We assume that other civilizations would use radio waves because we use radio waves. We expect them to build telescopes and cities because we build telescopes and cities. But what if alien life doesn't look or act anything like us? Imagine a civilization that communicates through chemical signals or uses ultra-fast light pulses invisible to human eyes. Or what if they've already uploaded their consciousness into machines, abandoning biology entirely? They might not live on planets anymore. They could exist on massive computers orbiting stars, quiet, efficient, and undetectable to our current tools. Even stranger, what if alien intelligence isn't confined to individuals at all? Maybe their minds are distributed, like a planetary hive mind, with no cities, no spacecraft, no need for technology in the way we understand it. How would we ever recognize something like that? This raises a critical point. We might be looking for life as we know it, and missing life as it actually is. Our telescopes, satellites, and algorithms are incredibly advanced, but they're still limited by human assumptions. For instance, when we search for exoplanets, we look for those in the habitable zones, where liquid water could exist. But that's because life on Earth needs water. What if alien life thrives in methane lakes, or in extreme environments, deep below ice or inside gas giants, places we'd normally write off as uninhabitable? The more we learn about life on Earth, the more flexible our definition of habitable becomes. We found life in boiling hydrothermal vents, in acidic lakes, and even inside nuclear reactors. Life is more adaptable than we ever imagined. So why not out there too? Even when it comes to detecting signs of alien technology, we might be too narrow. We mostly listen for radio signals, the kind humans began broadcasting in the early 20th century. But that window of communication might be short-lived. We're already replacing traditional radio with fiber optics, satellites, and digital encryption. Within a few decades, Earth might stop emitting detectable signals entirely. If aliens went through a similar technological shift, they might have broadcast for only a brief period, a blip on a galactic scale. There's also the issue of distance. Even if a signal was sent toward Earth 1,000 years ago, it might still be on its way. And if we sent one today, it could take centuries or longer to reach another civilization. We could be in a galaxy full of messages, all in transit, none arriving yet. In short, it's possible that the universe isn't silent. We're just not hearing the right frequency. So maybe the real question isn't, Where are they? Maybe it's, how would we even know if they were already here? And that leads us into some stranger territory. Because if aliens aren't showing up in obvious ways, not in ships, not in messages, then maybe they're hiding in plain sight. Or maybe the signs are already here, and we just haven't recognized them. For decades, people have looked up at the sky and wondered if we're being watched. Stories of strange lights, mysterious craft, and alien encounters have been woven into our culture. From the flying saucers of the 1950s to the modern-day term UAPs, unidentified aerial phenomena, sightings keep coming. They're reported by pilots, by civilians, even by military radar operators. And recently, governments have started to admit they've seen things they can't explain. But does that mean we've already been visited? It's tempting to think so. In 2021, the US government released a report acknowledging more than 140 incidents of UAPs that defied easy explanation. The footage shows objects moving faster and with more agility than any known aircraft. Some hover with no visible propulsion. Others accelerate instantaneously, defying our understanding of physics. It's hard not to wonder, could these be alien probes quietly observing us? Yet, for every jaw-dropping video, there's a mountain of skepticism. Most UFO sightings turn out to be mundane. Weather balloons, drones, military tests, or even optical illusions. The extraordinary claims require extraordinary evidence, and so far the evidence hasn't crossed that threshold. No alien spacecraft in a hangar, no crashed sources, no verified alien technology, just videos, anecdotes, and radar blips. There's also the scale problem. If an advanced civilization could travel across the stars, would they really crash here? Would their ships behave like the craft in our videos? Or would their technology be so far beyond ours that we wouldn't even recognize it? Some scientists argue that if aliens are observing us, they wouldn't risk detection at all. They'd use probes the size of grains of sand, hidden in asteroids or the outer solar system, essentially invisible to us. Another possibility is that alien visitation has already happened, just not in the way we imagine. Maybe life itself, even on Earth, is the result of alien influence. The idea of panspermia suggests that life can travel between planets on asteroids or comets. It's possible that microbial life started on another world and arrived here billions of years ago, seeding Earth long before humans existed. If that's true, then in a way, we're the aliens. Whether or not UFOs are evidence of visitors from beyond, one thing is clear. The idea that we're being watched captures the imagination. It speaks to our deep desire not to be alone. But so far the hard proof is missing, and that leads to an even stranger question. If the universe is full of intelligent life, and they've had billions of years to develop technology, why don't we see giant interstellar empires, city-sized spacecraft, or obvious megastructures around other stars? Why no Dyson spheres or cosmic engineering on a visible scale? Maybe the answer lies not in who's visiting us, but in what happens to civilizations before they ever get the chance to cross the stars. And that brings us to one of the most unsettling ideas in the search for alien life: the Great Filter. The universe is vast, ancient and full of possibilities. With trillions of planets and billions of galaxies, alien civilizations should be out there. They should have built, traveled, and left traces. Yet when we listen to the stars, we hear only silence. This is where one of the most haunting ideas in science appears, something called the Great Filter. It's a theory that asks whether there's a barrier, some invisible step, that prevents life from becoming intelligent, spacefaring, and galaxy-spanning. And if such a barrier exists, where is it? Behind us or still ahead? One possibility is that the Great Filter is already behind us. Maybe life itself, even simple single-celled life, and is extraordinarily rare. Perhaps the spark that happened on Earth is so unlikely that it almost never happens anywhere else. Or maybe the real bottleneck wasn't life's beginning, but the leap to complex multicellular organisms or the emergence of intelligence itself. After all, it took nearly 4 billion years for life on Earth to evolve into creatures capable of thought and technology. If this is the case, humanity is rare, maybe even unique. We don't see aliens because they never made it this far. That would mean we're early, one of the first intelligent civilizations in the universe, and the road ahead could be open. But the second possibility is far darker. What if the Great Filter isn't in our past, but in our future? What if the step that ends civilizations comes after they've reached the stars? or at least after they've begun developing technology. Every civilization that invents powerful tools also invents the means to destroy itself. Nuclear weapons, climate collapse, engineered pandemics, or runaway artificial intelligence. These aren't distant science fiction threats. They're real challenges we're already facing. Maybe the universe is silent, not because no one else tried, but because every society that reached our stage eventually wiped itself out. If that's true, then we're standing at the edge of an invisible cliff, and every silent star above us is a warning. Whether the great filter is behind us or ahead of us changes everything. If it's behind us, we're special, a cosmic miracle with a responsibility to survive and spread life to the stars. If it's ahead, then the silence of the universe isn't comforting. It's ominous. It means the universe is full of graveyards of civilizations that once were, but are no more. And yet there's a hopeful side. The great filter isn't just about aliens. It's about us. It's a mirror, forcing us to confront our own future. If the barrier is ahead, it's not inevitable. We can still choose to overcome it. We can avoid self-destruction, use our technology wisely, and make it past the point where others may have failed. We could become the civilization we're searching for, the ones who break the silence. Because if the great filter is real, then humanity's story isn't just about whether aliens exist. It's about whether we will pass the ultimate test and take our place among the stars, or become just another whisper in the void. We've talked about distance, technology, the odds, and even the possibility that civilizations self-destruct. But maybe there's something even deeper at play, something more philosophical, even existential. Maybe the reason we haven't found alien life is because we're not meant to, at least not yet. It's possible that intelligent life exists all around us, but we're simply not advanced enough to recognize it. Just as ants are unaware of the internet, skyscrapers, or human politics, we too might be blind to technologies or forms of consciousness that are beyond our understanding. Alien intelligence might not look like us, think like us, or exist in dimensions we can perceive. Their presence could be subtle, silent, and embedded in the fabric of the universe in ways we haven't yet begun to imagine. Some thinkers have suggested that the universe itself could be a kind of simulation, a vast, cosmic experiment being run by an intelligence far beyond anything we could comprehend. In that case, perhaps the lack of contact with other civilizations is part of the design. Maybe we're being observed, maybe we're being tested, or maybe, like characters in a story, we're not supposed to know about the authors until the final chapter. Even outside the simulation idea, there are natural explanations that feel just as unsettling. It could be that the timing simply doesn't line up, that life in the universe arises in staggered waves. We may be in the earliest wave of intelligent life, born just before others arrive, or just after the last wave faded. In that case, the silence isn't ominous. It's just a reflection of cosmic timing. We're early or late. There's also a humbling possibility. Maybe we're not interesting enough. We assume that contact with aliens would be a huge deal. To us, it absolutely would be. But what if we're not the center of the story? To a civilization millions of years more advanced, humans might seem primitive, like watching smoke signals when you're using quantum communication. They may have already scanned our world, watched our development, and simply moved on. We're not a threat. We're not useful. Not yet. And then, of course, there's the spiritual angle. The idea that the universe holds mysteries we aren't meant to solve quickly. Maybe finding other intelligent life is something that requires not just technological progress, but emotional, ethical, or even spiritual maturity. Maybe the universe is waiting for us to evolve, not just scientifically, but philosophically, until we stop fighting each other, poisoning our planet, or clinging to tribalism. Perhaps we're not ready for what's out there. This perspective may sound frustrating or even hopeless. But it's not, because it suggests that the silence of the stars isn't empty. It's full of potential, a quiet stage before the curtain rises, a universe full of life, waiting for us to become something more. So maybe we're not meant to know right now. Maybe the next chapter of discovery isn't about pointing telescopes further out, but about looking inward, asking who we are and who we're becoming. Because if the truth is out there, we may need to change here before we ever find it. When we hear the word alien, most of us picture something familiar, maybe the classic image of a humanoid figure with big black eyes, smooth gray skin, and a mysterious spaceship hovering above. But here's the thing, that's not science, that's storytelling. The real question is much more fascinating. If life exists elsewhere in the universe, what would it actually look like? To even guess, we have to start with what we know: evolution. Life on Earth has taken forms shaped entirely by its environment: gravity, atmosphere, temperature, available elements. Everything from the wings of birds to the bioluminescence of deep-sea creatures evolved as a response to specific challenges. So if alien life exists on a world unlike Earth, with different gravity, air, light, or pressure, then their forms could be absolutely unrecognizable. On a low-gravity planet, creatures might grow taller and thinner, with spindly limbs or floating capabilities. On a high-gravity world, life forms might be short, strong, compact, built like tanks close to the ground. If the atmosphere is thick with gas or clouds, aliens might develop sonar like bats instead of eyes. In total darkness, they might see using electrical fields or vibrations, like deep-sea fish or insects. In underwater environments, intelligence might evolve in cephalopod-like beings, squishy, adaptable, with distributed brains and no bones at all. And here's a mind-bender. What if some alien life doesn't use carbon at all? On Earth, life is carbon-based because carbon is abundant and flexible, forming long chains that make up DNA, proteins, and cells. But in theory, other life could be based on silicon, which is just below carbon on the periodic table. These beings might have entirely different metabolisms, maybe thriving in hotter, drier environments, like volcanic planets or molten surfaces. A silicon-based life form could have a body more like a crystal or rock than flesh and bone. But biology might not even be the final form of intelligence. If civilizations survive long enough, they might transition into machine life, uploading consciousness into synthetic bodies, abandoning biology altogether. These entities wouldn't age, wouldn't need food, and might not even live on planets. They could roam space inside megastructures or self-replicating probes, harvesting energy directly from stars and communicating through light or magnetic fields. We might not be looking for tentacled monsters or intelligent apes. We might need to be looking for AI civilizations, invisible cloud-like intelligences, or machines the size of grains of sand quietly observing the universe. If aliens are truly advanced, they might have mastered physics to a level that lets them manipulate space-time, hide from detection, or exist in dimensions we can't perceive. To them, we might look like bacteria. Interesting maybe, but not on their level of awareness. There's even a possibility that alien life is already around us, not in the form of ships or creatures, but as patterns, phenomena, or physics we simply haven't understood yet. Think about how long it took for humans to understand germs, atoms, or gravity. What if alien intelligence is so subtle that it doesn't look like life at all? The truth is, we may be completely unequipped to imagine what aliens look like. Our brains evolved to survive on Earth, not to comprehend life from across the galaxy. But that's what makes the search so exciting, because every time we look up, we're not just asking if someone is out there. We're wondering what form life itself might take when the universe writes its own version. And if we ever do make contact, even with a microbe, or a whisper of non-human intelligence, it will be the single greatest discovery in the history of science. It will redefine biology, religion, philosophy, and what it means to be alive. Because aliens might not look like us, but if they exist, they'll tell us more about ourselves than we ever expected. We've spent this entire journey asking where the aliens are. But what if the answer is closer than we think? What if the aliens are us? This idea might sound like science fiction, but it's rooted in a real scientific concept called panspermia. The theory that life can travel from one world to another, hitchhiking on asteroids, comets, or even spacecraft. Over the past few decades, scientists have discovered that microbes can survive in the vacuum of space for years. They can endure freezing cold, intense radiation, and massive impacts. We've even found Martian meteorites on Earth containing structures some think could be fossilized bacteria. It's entirely possible that life didn't start on Earth at all. It could have begun on Mars billions of years ago, when that planet was warmer and wetter than ours, and then been blasted here by an asteroid impact. Or maybe it came from even farther away, a distant star system whose debris wandered into our solar system. If that's true, then Earth isn't the birthplace of life. It's just the current home. In a very real sense, we're already aliens. This idea reshapes everything. When we search for life beyond Earth, we might not be looking for something completely foreign. We might be looking for our distant cousins. Microbes on Europa or Enceladus, for example, could be related to us at the molecular level, sharing the same DNA ancestry. If that's the case, then the question isn't, are we alone? But where else has life from our family tree ended up? And there's an even wilder twist. What if intelligent life itself didn't originate here? Some speculative theories suggest that an advanced civilization could have seeded life intentionally across the galaxy, a concept known as directed panspermia. In this scenario, we might be the descendants of a project launched millions or even billions of years ago by beings far older and wiser than us. We wouldn't just be looking for alien civilizations, we'd be looking for our ancestors. Whether accidental or intentional, panspermia suggests that life isn't locked to one world. It spreads, it adapts, it survives, and that means the seeds of life could be everywhere, waiting for the right conditions to bloom. So when we look at the stars and wonder where the aliens are, maybe the better question is, how far back does our own story go? Are we Earth's first children, or visitors who've simply forgotten where we came from? Because if panspermia is true, then every question about alien life circles back to us. We're not just searching for extraterrestrials out there. We're searching for our own origins, and for the architects of life itself. Imagine the moment. The telescope picks up a signal, a narrowband radio pulse that repeats every 10 seconds, coming from a star system 80 light-years away. It's not random. It's structured, intelligent. After decades of silence, we've received a message, and just like that, everything changes. First, the scientists would double-check, triple-check. They'd run the data past every agency, every lab. The assumption at first would be that it's a glitch, a satellite, some kind of interference. But when the evidence holds, the world would hold its breath. The official announcement would be cautious, maybe even cryptic. We have detected a signal of unknown origin. But within hours, the truth would leak. And by the next morning, it would be on every screen on Earth. Now imagine the global reaction. Some people would cry, some would cheer, some would panic. Markets might crash. News anchors would stumble through breaking reports. Religious leaders would scramble to interpret the meaning. Is this proof of a creator, or something else entirely? Scientists would become celebrities overnight. SETI would be flooded with calls. The internet would spiral into chaos. Memes, conspiracies, fake versions of the message, and 1,000 opinions on what it means. And then comes the biggest question of all. What do we say back? Do we respond at all? Some experts would say yes. This is history, the start of a dialogue with another intelligence. Others would argue absolutely not, that responding could be dangerous, like shouting in a dark forest without knowing what's listening. Debates would rage across TV, academic journals, Reddit threads, and late-night talk shows. Meanwhile, linguists, mathematicians, and cryptographers would work around the clock trying to decode the message. Is it math, music, images, DNA, a star map, a warning? The most terrifying possibility is that the message contains information, technology, blueprints, or knowledge far beyond our current science. What if the signal teaches us how to cure diseases, or build machines that bend space and time? Would we use that knowledge wisely? Would governments hoard it? Would it unite us, or divide us? Alternatively, what if the message is simple, just a greeting, or worse, a countdown? The psychological impact alone would be enormous. For some, it would be proof that we're part of something bigger. For others, it would shatter their worldview. Some would fall into existential despair. Others would feel hope like never before. Entire philosophies and belief systems would have to adapt. Humanity's story would suddenly feel much, much bigger, and our place in the universe much smaller. And that's if the contact is just a signal. If it's more a probe landing or a ship in the sky, the shockwave would be even greater. Governments might try to control the narrative. Militaries would be on high alert. The balance of power could shift overnight. And yet, in the middle of all that noise, one question would remain: who are they? And what do they want? Because contact isn't just about finding life. It's about what happens after, how we respond, what choices we make, whether we reach out with open hands or clenched fists. But maybe, just maybe, that moment would be the start of something bigger than fear. Maybe it would remind us that, for all our divisions and arguments and chaos, we are one species, one planet. And maybe the only way forward is together. Because when we finally make contact, it won't just be the end of one story, it will be the beginning of something entirely new. We've searched the stars, run the numbers, listened for signals, explored theories, and still there's silence. Maybe it's distance, maybe it's time, maybe we haven't looked long enough, or maybe there's no one else out there. It's the possibility no one really wants to face, that we are the only intelligent life in the universe, that after billions of years and trillions of worlds, Earth is the lone island where consciousness woke up. That we are not just rare, but utterly alone. It's a heavy thought, because the universe is unimaginably vast, and silence on that scale feels almost cruel. We want to believe in connection, in others, in meaning, to find that across all that darkness, there's no one to talk to, no one watching the same stars. It feels like the deepest kind of loneliness. But maybe in that loneliness there's also something else, something profoundly important. Because if we're alone, then life is more fragile than we ever imagined. Intelligence isn't common, it's precious, and we are the only ones who carry it. There are no backup civilizations, no second chances on another planet. We are it, and that means this little blue world floating in the black is sacred in a way we've never fully appreciated. Every forest, every species, every culture, every child, it's all part of the only known experiment where the universe became self-aware. If we are alone, then the responsibility is enormous. To protect life, to preserve beauty, to understand as much of the cosmos as we can, not just for us, but because we may be the only ones who can. We're not just a species, we're the voice of the universe trying to understand itself. And maybe that's what makes it all worth it, because even if we never find aliens, even if the stars stay silent forever, it doesn't mean the story ends. It means the story is ours to write. We're not just waiting for contact. We are the contact. We are the explorers, the builders, the ones who dream. So we look up, not out of fear, not out of loneliness, but because we are curious and courageous and alive. And if one day we do hear that signal, or see that ship, or discover we are not alone after all, then we will have something beautiful to say.